Hello everybody, my name is Simeon Nanowski, and again I'm your instructor for Statistics for Public Policy course. And today we're going to be doing Chapter 2, and this is the first part of descriptive statistics. Okay, and today we're pretty much covering ways to represent data, graphical ways and tabular ways. Okay, so summaries of data. Okay, summaries of data is what we'll be doing. And now let's start the slideshow. Okay, everybody, from current slide. Okay, so this is the book, and again the chapters are in the book. Okay, and I'll post this video lecture along with the PowerPoint. Okay, and Moodle. Okay, so let's first talk about data. What are we talking about? There's two types of data. Quantitative data is information about quantities. That is information that can be measured and written down with numbers. These could be categorical, for example, integer numbers, or continuous real numbers. Example of this is height, weight, shoe size, hair length, age, mass, temperature, time, and price. Example. Qualitative data, on the other hand, is information about qualities. That is, it is information that can't be measured in numbers and in general in categories. It is a categorical variable like gender, hair color, eye color, profession, and coursework. Okay. So these are types of data. And you can summarize data, at least we'll talk about here, using a frequency distribution, which is just kind of like a chart or a tabular summary of the data showing total number of observations per category. So it's not graphical in a sense. And graphically, you can also have a bar chart or a pie chart. A bar chart shows a frequency per category on a bar, and a pie chart shows frequencies on a circle on a pie. Okay. Here's an example. Guests at the Morada Inn were asked to rate the quality of their accommodations as excellent, above average, average, below average, or poor. The ratings provided by a sample of 20 guests are, okay, so 20 people were asked. Some of them said it's poor, above average for most. One person looks like said it's excellent, and below average, one person, I guess, or two people, three people. Average also has some, okay. So let's summarize this. First, we'll do a frequency distribution. So you put the rating on the left side there, okay, and the frequency on the right side, like this, okay. So frequency, what does frequency mean? How many times this rating occurred is frequency. Okay, like that. Then what you can do is you can convert the frequency into a percent. Okay, how do you do that? Well, since there are 20 total, you have to multiply the number by 5 to get to 100. Okay, so for example, if there's poor, okay, if poor is 2 people ranked as poor, you multiply by 5, get 10. Right, you get 10 here. Below average, well, 3 people said below average. Excellent, 1 person. So you have to multiply by 5 to get up to 100. Okay, and this is frequency. Okay. Okay, let's move on here. Okay, Morada Inn quality ratings. This is what's called a bar chart, and instead of kind of a numerical summary, you can see it here visually. The frequency is on the left, and the ratings on the bottom. By the way, before I continue, I forgot to mention, you guys are master students. So there's some expectations I have for you. And one of them is to kind of try and figure out stuff on your own as you're reading. Please read the book, try and figure out stuff on your own. And this chapter I'm skipping over a little bit faster because I assume this is stuff that you can figure out on your own very easily. It's not that complicated. Things it's about graphs and how to represent data with graphs. And I think that most of you should have already done this by now, since you're master's graduate students. Okay, graduate means you already have a bachelor's degree. So for you, this should not be an issue. It should not be a problem. Okay. So I'm going to go a little bit faster in this chapter. Okay. Again, you can do it in a pie chart like this. Okay. Now, how do you do these? How do you provide a frequency distribution and provide a chart of a summary? You can use Excel to do this. I've already done it, actually, in Excel. For example, here's a problem, a practice problem, if you want. 6 guests are staying in Astana. We're asked to rate the quality of their accommodations. A for excellent, B for above average, C for average, D for below average, and F for poor. So these are like letter grades instead. So Astana, there were 6 guests, and the ratings are AA, B, C, BB. So everybody is either average, above average, or excellent. Nobody gave D or F. Okay. So the first step is provide a frequency distribution using codes from Excel. Provide a bar chart summary of the frequencies. So I'll tell you what. The book is very good in this case because actually in the appendix of the chapter 2, the book shows you how to work with Excel. And in every chapter actually, if we're doing some kind of statistical test or something like this that requires a computation or just showing us something in Excel, the book shows you how to do it in Excel in the appendices of the chapters. Okay. So if you guys are not sure what to do, that's why it's a very good book, is because it shows you what to do in Excel. Watch. I think I have it here. Okay. Watch. This is chapter 2. This is the appendix. Using Excel for tabular and graphical presentations. So the first one here, show you how to do a frequency distribution using categorical data. Basically, what you do is, if you read here, and I'll show you everything, okay? It's page 76 in chapter 2. I posted this, all right? Basically, you go here. You type the ratings here on the left side. They're AA, B, C, BB for the 6 people. Then here you have type, grade type. So you know what the grades are. And here you have frequency. Okay? So this is what you do if you just follow the book. Now, let me tell you something. I didn't know what to do, okay, until now, until yesterday when I did this, actually. So I didn't know this myself. I just looked at the book and I figured out what the book was saying, and now I'm teaching it to you. But before that, I didn't know this. So what I'm saying, obviously I don't know everything, and I'm not assuming that you know either. But what I know what to do is how to figure out stuff on my own. So again, it's a very important thing. Just read the book, try to understand things on your own, okay? Try to see what to do on your own, It's very important skills, these skills, because for simple things that are well explained in the book, there's no point for me to show you. But anyway, I'll just show you because I've done it already. And I'm not going to do everything for you, obviously. You can figure out the rest. But how do you see it? You type in the following. Count if, so you're telling the program to count the ratings here. There's 6 of them. And you're saying how many, to tell you how many are A's. Count if A2 to A7, comma B2. So B2 is this one, to tell you how many A's there are. This one also counts A2 to A7, but tell you how many B3s there are, and so forth. What about D's and F's? They have to be 0, right? Because there's no grades of F and D. Anyway, we would like to do like this. Count for F, right? Count if, you select here range, comma, and you select here this one. And it should spit out 0 because there's no F's that are in column A, right? So here are the letter grades. Then what do? You want to create a bar graph. You insert charts like this one. Bam. 2 A's, 3 B's, 1 C, 0 D, 0 F. Make sense? Makes sense. Okay. A bar chart like this. Okay, everybody? Okay, so moving on in lecture then. Provide a bar chart, provide this and this. So the frequency distribution is this. Some in A's, B's, and C's, and D's, and F's are. And this is the bar chart here, okay? Okay, we move on now. One second. Let's see where this. It's right here. Okay. You can also have, if you have a continuous variable in particular, you can use what's called a histogram, and you can divide your data in ranges. So this is ranges for people's heights. Height is a continuous variable, so nobody is a precise height. You cannot have somebody. Everybody's height is different, even by a little bit. Nobody has the exact same height. So here on the x-axis are people's heights and ranges. So this can be from a range from maybe, I don't know, 1.60 m to 1.65 m. 1.65 m to 1.70 m. 1.70 m to 1.75 m, 1.75 m to 1.80 m. Maybe the most common one, okay? So these are heights of people, and the most common is between 175 or 170 and 180, maybe, or something like this. And so you divide it up into ranges, and you group the people into corresponding ranges in a sense, okay? So, but it's up to the researcher to divide how they want this. And so you divide it up into categories of heights in this case, okay? So that should make sense, okay? Now, this is called a symmetric histogram because the average is the middle also. The middle person. And this case is skewed to the left, okay? Because the average is less than the middle. So the middle is somewhere here, or the most common one, right? Maybe somewhere here. The average is going to be here. Skewed to the left. The left because the tail side is to the left. Okay? So you got, in this, as exam scores in particular, what is it saying? That the higher the exam scores, you got a lot of people with very high exam scores and a few that really failed it. Right? Okay. Skewed to the left. Skewed to the right, it means that distribution has a tail that's to the right. In this case, the average is a lot higher than the median or the middle one. Okay, the average, and we'll talk about those in the next chapter, is a lot higher in this case. Okay, an example is housing values. You'll find some housing values in the millions here, right? And it will make the average price of a house all the more expensive. Although most houses are just, I don't know, $50,000, or let's say 10 million tenge. By the way, I looked at housing values in Astana. Most of them are around 15 million tenge apartments. I looked at apartments in Astana. Most of them are 15 million. So this corresponds to maybe actually a range between 13 million and 16 million. This looks kind of like the range that I got. Okay. And you got a low amount that are in the millions of tenge, maybe like 100 million, 50 million, very, very expensive like this. Okay. Okay. Highly skewed to the right, executive salaries. Okay, for example. Okay. So far we looked at one variable at a time. People's heights, housing values, for example. Often a manager is interested in a tabular or graphical summary that will help understand the relationship between two variables. Cross-tabulation is a method for summarizing the data for two variables. Okay. So what you should do? Okay. Let's see here. The number of Finger Lake homes sold for each style and price for the past 2 years is shown below. So you have two variables. One variable is price range. Is the home, let's say, expensive, doroga, or cheap, deshevля? Two types of houses, cheap or expensive. Okay. And home style then is the home colonial, log split, or A-frame. And then you can have a combination of the two variables. So that's why this is cross tabulation, because you can have a home that's colonial but cheap, right? Or you can have log that's cheap also. Just based on this, it looks like the A-frame, almost what? 3 out of 15 is exactly 1 out of 5. 20% are expensive for the A-frame and 80% are cheap. Do you see this? So the A-frame appears to be kind of on the cheaper side, I would say. On the other hand, the log divided by 2, 3. Divided by 2, 7. So 3 out of 7, I would say almost, what is 3 out of 7? What is it? I think around 60% or so of the log. More than 60, check it out. Not 3 out of 7. This is 6 out of 20. Right? So it appears that 70% of the log is expensive and 30% is cheap of the log home. So the log is kind of the more expensive style of thing. Okay. Anyways, so this is two variables. This is a way to represent the data with two variables. Okay. Again, guys, don't focus too much on the chapter. I'm not really going to test you over this because I think it's very common sense things, really. And you might have seen these before, actually, right? Let me know if you have not. If you haven't seen graphs, charts, a lot of those were when I was taking college tests. You know, sometimes to get into a baccalaureate degree or something like this, you need to take a test of some kind. And they have a lot of these graphs, charts, interpretations of data. Okay, especially in the United States. You know, I lived there a long time, since I was a little kid. Actually, I lived in the United States, and there they have different tests to go into college, like the ACT or the SAT, and there they have a whole bunch of these data charts and graphs. Some of the tests you have to interpret what they're saying, right? So this is really, I think, for high school students, and you guys are graduate students, so you should have seen this a lot, right? Okay, everybody. Okay, everybody. Now we're going to move on. Okay. Atka. Taka, taka, taka. Right here are the totals. This total is, guess what? Represents the price range here. So you have a little more cheaper homes, 55 cheaper homes and 45 expensive homes. Then you have a total of 30 colonial homes, 20 log homes, okay? Like this. Okay, everybody? Okay, okay. Okay. Now you want to convert into percentages. Here there is row. Here there is row percentages. And basically, what is the idea here? Okay. According to the row, it's going to add up to 100. Okay. So you isolate. You only look at price for less than $200,000. Okay. Okay. And you add up the total amount. The total amount of less than 200. In this case, the total amount, right, is 55. So you need to multiply 55 by a number. Okay. What number would you multiply 55? Okay, to get to 100. And that same number, you multiply the numbers here to get these percentages. Okay, it's that simple. I'll show you. I'll show you what to do. Let's see. Okay, the first one is 18. Okay, so let's see if we're right. Okay, so what should you do then? You should bam, like this. Okay, do you see the calculator here? And then what do you do? 55 times x equals 100. So I do 100 divided by 55, bam, 1.81. Okay, so this I multiply every single number there. Colonial, how many colonials were there? 18, right? If you go back, you'll see there were 18. So I multiply 1.81 or 1.82 in this case, if I round, okay, times 18. And bam, I get the colonial here. You can do this for all of them here. On the bottom row, you multiply what number multiplied by 45 equals 100. So it's going to be 100. Okay, everybody, divided by 45. So in this case, you multiply the bottom row by 2.22. And for example, if we go back chart, this is 12. Or let's do the other one. 3. Okay, the A-frame is 3 times 2.22. okay, is exactly 6.67. We know that, right? It's very easy to multiply that. Okay, everybody? Everybody getting this? It's easy, right? Easy, easy. It's nothing that complicated, okay? Okay. Start. Okay. Anyways, in most cases, a graphical display is more useful than a table, okay, for recognizing patterns. And a scatter diagram is graphical representation of ratio between two quantitative variables, okay? One is shown on the horizontal axis and one is shown on the vertical axis, okay? And the general pattern of the plotting shows the ratio between the two variables. A trend line provides an approximate relationship. So the relationship is positive between two variables. It might look like this. Okay. The relationship is negative. It might look like this. And this is no apparent relationship here. Okay. Let's get an example. The Panthers football team is interested in investigating the relationship, if any, between interceptions made and points scored. Okay, like this. Number of interceptions on the left. Let's see, points scored on the other one, on the other variable. Okay. So now we're going to plot those in x and y axis. Okay. Bam. Number of points scored on this axis, number of interceptions. So when there's one interception, there is one case that how many? 17 points were scored. In one case, there were 14 points scored, or something like this. Okay. So the more interceptions, generally, the more points that are scored. This is what it's saying. Okay. Yes. Another. Okay. Insights gained from a scalar diagram. Scalar indicates positive relationship. Okay. The higher the points scored is what we just said. Okay. Notice the relationship is not perfect. All points in the scattergram are not in a straight line. Okay. Now we can do another chart, side by side bar chart for graphical displays, and it might look something like this. The frequencies, instead of putting numbers, I'm just putting it in a bar graph. Okay. And there's two bars on each one depending on the price. Okay. Okay, this is a stacked bar chart, a little bit more different. And this is the end. Okay, everybody? So, this is chapter 2. Now we'll take a little break and we'll continue on to chapter 3, which is the second part of descriptive statistics. So please take a break now. Thank you. Hello, everybody. We're back again here. Okay, so now we're on chapter 3. Okay. 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 So this next chapter will be about, we talked about data and how to summarize data on a graph, the last chapter 2. And this chapter will provide numerical statistics based on data. Generally, data sets are large and sometimes graphical summary is not feasible sometimes, and you just want fast statistics of the data. And there's two major types of statistics that you can get. Ones are measures of location. Where is the data? This is also called a measure of central tendency. And the other one is a measure of variability. How spread out is the data? Okay, okay, everybody. Okay. Anyways, let's first start with measures of location. What am I talking about? This is kind of like it could be the mean, the weighted mean, median, geometric mean, mode, percentiles, and quartiles. Okay, what am I talking about? So the question here is, where is the data? I'll give you an example. So a measure of location is, for example, the average of the data. Okay, for example, if I give students tests, exams, the average score is 80%. Maybe I can say, okay, the test scores are roughly 80%. Okay, so this is the average description of test scores. For example, you can describe the where are they about by using the median, the mean, okay, the weighted mean, geometric mean. Okay, now what is the mean, average, expected value? These are all the same thing. If you talk about somebody talking about the average test score, or the mean test score, or the expected value of the test score, they're talking about the same thing. Okay, and it's because the most important measure of location, and the location you've heard of generally is the mean. Again, it provides a central location, is the average of all the data values, the average of them. So how would you proceed? The mean is known as x bar. So you sum up all of the data points, in a sense, all the data observations in this case, and you divide by their total number. If I have 10 different test scores, I sum all of them up and I divide by 10 in this case. Okay. Okay. Here's an example of apartment rents. I think we did this in chapter 1. Okay. But anyways, there's 70 apartments. They're randomly sampled in a small college town. The monthly rent prices for these apartments are listed below. Okay, everybody? A total of 70 apartment rents. Okay? So I sum up all of them, all of the apartment rents, just visually. How much do you think the rent is? I would guess a good measure of central location. I'm seeing numbers here in the 400s, mostly in the 400s, a few in the 500s, and a few in the 600s. So I would say, I think maybe it's close to 500, the average, or maybe 490, around 500. Okay. Okay. So my guess is 500. Okay, everybody, is the average of all of them, just by looking at the numbers. Now, how do I get an exact number? I need to add up all of the numbers here and divide by 70. And this is what they do here. Okay. So the average is 490, actually. Okay. 0.8. Okay, it seems reasonable. Okay. What about the weighted mean? In some observations, the mean is computed by giving each observation a weight that reflects its relative importance. I'll give you an example. The choice of weights depends on application. The weights might be the number of credit hours earned for each grade, as in GPA. Another weighted mean computations, quantities such as pounds, dollars, or volumes are frequently used. Okay, I'll give you an example. Okay, so this is the formula, and W is the weight here. Okay, like this. Okay, watch. Ron Butler, a home builder, is looking over the expenses he incurred for a house he just built. For the purpose of pricing future projects, he would like to know the average wage he paid the workers he employed. Listed below are categories of workers he employed along with their respective wage and total hours. Okay, so some of them got paid $28.72, but they didn't work that many hours, or $24.16, but they didn't work that many hours. A laborer, on the other hand, does not have a high wage, but he worked a lot of hours. So first, I need to get the total expenses. And then I divide the total expenses by what? By total hours to get the average expense, in a sense, or the average wage. And this is what's been done here. In a sense, the weight is the total hours. Okay, this W, the sum of the W's. The W is the amount of hours worked. In this case, okay, like this. This 31,000, this is the total expenditure on wages divided by the number of hours will give the average wage per hour. Cents, okay, which is about $20. On the other hand, this is saying the equally weighted simple mean is 21.21. That means if I just average these wages without taking into account how many hours are worked, I'll get 21.21. Okay. Okay, so this is enough for this. The next one is the median. The median of a data set is the value in the middle when the data items are arranged. So which ones are the important measures of location? The mean, the median, and perhaps the mode. But this is also another very important measure of location, is the middle person or the middle value in the data. Okay. Whenever data have extreme values, the median is preferred as a measure of central location. Okay. So let's say a few people on the exam failed the test, so they got a zero. They didn't show up for it. That means the exam might be, the average might be for the exam 60%, maybe 70%. However, most people scored above 70%. So the average is not maybe truly representative of central location. A better one would be the median. Or what did the person in the middle get on the exam? Okay, that's what it is. Okay. One example is the property values. Some property values are just the millions and millions of dollars. It's better for them not to be not taken into account. So just the middle house, in a sense, should be the indicator for the central location, okay, of property values. Okay. So how do you find the median? First, you need to add up the data in ascending order. Then the median is the middle number. Okay, everybody? Okay. What if you have an even number of observations? Then again, you line them up in ascending order. And the median is the average of the middle two. In this case, 22.5 is the median. Okay, everybody? Okay. In this case, the apartment rents, since there's 70 of them, okay, divided by 2 in this case, okay, it's a 35th and a 36th. number are the middle ones. The average is 475 for both. So that's how much the median is. Okay. The next one is the geometric mean. This one is a little bit more tricky. I'm not going to be testing you over it on this one. But anyways, it is often used in analyzing growth rates in financial data, where arithmetic mean might provide misleading results. Should be applied anytime you want to determine rate of change over successive periods. Okay. So this is used when you want to talk about growth rates, an average growth rate, for example, okay? Or some kind of rates, okay? So what do? You pretty much take this, you multiply the data and you take the nth root to get this geometric mean, okay? And for example, if I have a rate of return here, let's say period 1, something dropped by 6%, maybe the value of a house. You know, right now in Astana, I'm guessing maybe housing prices are decreasing because there's going to be a recession soon, right here. The economy might be going very bad with this coronavirus. So housing prices might be dropping. And so this is saying, suppose the first time it dropped by 6%, 8%, and 4%, then it increased by 2%, 5.4%. The question is, what is the average rate of return or the average growth rate per period? Okay, you convert these into growth factors first, then you multiply the growth factors together, and you take the fifth root, and then the average growth period the growth rate per period is minus 2.248%. Okay, everybody? So that's how it is. Again, I'm not going to test you. It's kind of tricky stuff, this geometric mean. But let me tell you intuitively where it's used, and you can figure it out on your own if you would like. Okay? Try this exercise on your own. Okay? Suppose I started the number 100. I increased by 10%. So now I should have 110 one year. And the second year, I decreased by 10%. Okay, the second year. If I took the simple average, what is the average growth rate? I would get 0 because first time it went up by 10% and the second time it went down by 10%. But what happened to the value the second time? So first it was 100. It went up to 110 and then it came back down not to 100 because a drop of 10% from 110 is about 11. So it went down to 99. So actually there is actually some loss there after 2 periods. Okay, everybody, there's some loss. And so the average growth rate is about negative 1%, negative 0.5% in this case. Okay, everybody? Okay. And this geometric mean will actually be able to calculate this. How would you calculate it? Well, you multiply what? The first time it went up. Let's take it. I'll show you. Okay. The first one, it went up by 10%. So I'll put this growth factor 1.1. Okay. and the second time it went down by 10%. Okay, so growth factor is 0.9. So I multiply 1.9, 1.1 times 0.9 because it went down by 10%. So from 1 to 10. So I multiply this by 0.9. You see this 0.99. And then I take, in this case, I'll take the square root and I'll subtract 1. And should be about negative 0.5%, okay? Where is this square root? The amount, here you go. Then I subtract 1, okay? And I multiply by 100. You just followed the formula. Look, negative 0.5% on average. On average is the average growth rate. Because at the end of the day, the value actually contracted. Okay, does that example make sense? It was first 100, 110, and then the second period it went down to 99. So the final value went from 100 to 99. It contracted. In 2 periods, it contracted by 1% in a sense in 2 periods. So in 1 period, it contracted roughly by 0.5% in 1 period. Or the average contraction per period is 0.5%, roughly. Okay? So that's how you do it, and that is the whole purpose of behind this geometric mean. Okay, everybody. So let's move on now. Okay. Okay. The next one is the mode. And the mode is the most common value. If the data exactly has 2 modes, the data are bimodal. Maybe you can have more than 2 modes. So for apartment rents, which one is the most common one? First, you need to line up again from the least to the greatest in ascending order, and you look for them. Maybe 600 is very common here, right? 500 is also pretty common. 445 has 5 of them here, okay? So I think 445 is the most common one. Let's see. Okay, actually it's 450. That occurs 7 times. So this is the mode. The most common occurrence of the number is the mode. Okay, everybody? Okay. The next one, so we covered mode, now is percentiles. A percentile provides information about how data are spread over the interval from the smallest value to the largest value. Okay. The median is the 50th percentile. The median. Okay, I'll give you an example. Now, let's talk about admission test scores for colleges and universities are frequently reported in terms of percentiles. Okay. The pth percentile of the data set is the value such that at least p% of the items taken this value or less, and at least 100 minus p% of the items taken this value or more. Okay. So for example, if I talk about the 90th percentile of the price, let's go back to the prices in the previous example. If I talk about the 90th percentile, I'm talking about the top 10%. And what value is the 10th on the 10th 90th percentile? Is 600. So about the 90th, we're about 600. Okay, these are the top 10 percent of values here, and the 600 is the first one of the top 10. This is the 90th percentile. Then the 99th percentile, or something, the 98th, will be 615. It will be one of the last ones. On the other hand, the 10th percentile will be about 435, the 10th one. Okay, the 50th one is the median. I forgot what the median was. I think it was 475. The median maybe. Okay, right over here, the median. This is the 50th percentile. Okay. Okay, so you guys are getting this. Okay. How do you compute it? Again, arrange it from ascending order. Then compute the index, I. This is the position of the pth percentile, the position. Okay? So I equals P. This is the percentile you're interested in, divided by 100 times N, which is the total number of data points. Okay, everybody? If I is not an integer, round up. If the bth percentile is the value in the ith position, okay? If I is an integer, then the pth percentile is the average in the I and I plus 1 positions, okay? I'll give you an example. Suppose I'm interested in the 80th percentile. For P, I put 80, okay? Divided by 100 times 70. 70 is the total number of observations or data points, okay? When you multiply this, you get 56. So you count 1, 2, 3, 4, 5, 6, 7 until you reach 56. I think it's gonna be somewhere here. So you count from the least to the greatest, you count 56 times, okay? This is 70. So this is, yes, it's about 10 each one. So 70, so this is 70, right? So this is 61, 60, 59, 58, 57, 56 is this one. And because it's an integer, it's between the 56th and the 57th number. The average of these two numbers, it's supposed to be, okay? The average of 535 and 549. Let's see if I'm correct. There should be a solution here, okay? Does this make sense? Again, you put on the percentile here, you multiply by the total number 70, it gives you a position number. Because the position number is an integer, which is a whole number. That's what an integer means, a whole number. You get the average between the 56th position and the next one, which is the 57th position in this case, okay? See? Averaging the 56th and 57th data values. Does that make sense? I average these two, and so my 80th percentile is the average between these two. And in this case, it's 535 plus 549 divided by 2, which is 542. Is the 80th percentile. Okay. Okay, everybody. Okay. That means at least 80% of the items take on a value of 542 or less. This is the interpretation of it, okay? At least 20% of the items take on 542 or more. There's the interpretation of that one. Okay? What is a quartile? A quartile is also a percentile, but in specific places. The first quartile is the 25th percentile. The second quartile is the 50th percentile. It's called the median. And the third quartile is the 75th percentile. Okay, everybody? Okay. So now we'll compute quartiles. Okay. Let's see. The third quartile, 75th percentile. Which one is it? So in the formula here, you put P as 75 divided by 100 is 3/4. 3/4 times 70. Well, 3 times 70 is 21. 210 divided by 4. 210 divided by 4 is 52.5. And then I round up. Because it's not an integer, I round up this time to 53. So I count the positions until 53. Okay? And so the number is 525, and then the third quartile is 525. That means 75% of the data is below 525. And 25% is above it. Okay? Now, what about the first quartile? We talked about it. It's going to be 25 over 100 times 70. 1/4 divided by 70, so 70 divided by 4. Exactly. Two. I think it should be 1.75. Let's see, 70 divided by 4. So in theory it should be 17.5. Okay. 17.5 rounded should be 18. So it's 18. This is the first quartile. So you count 18. Intuitively, just look, here's the first 10. And then here I count to the 8th one. So 18, the first 10 are here. Okay. First 10 are here. And then I count to the 18th one, which is here. So the first quartile is 445. Okay, everybody? Okay. Now, let's take a little break here. We talked about measures. We just finished talking about measures of location. Next, we're going to talk about measures of variability. So please take a break now. Okay? So next a half an hour we'll spend on this. Okay, continuing on. What is measures of variability? Okay, so this is how far spread out the data is. Basically, it is often desirable to consider measures of variability or dispersion as well as measures of location. Okay. For example, in choosing supplier A or B, we might consider not only the average delivery time for each, but also the variability in delivery time for each. Okay. So here we'll study range, interquartile range, variance, and standard deviation. the 4 measures availability. The simplest one is the range. The range of data set is the difference between the largest value and the smallest value. Okay, and this is the simplest measure of availability. How much rent is between the minimum rent and the maximum rent. It is very sensitive to the smallest and largest values of the data, so it might not be a very good representation of how spread out, in this case, the rents are. Okay, because I'll get the cheapest rent and the most expensive rent, and if I get maybe $200, I'll say that there is a $200 difference between the most expensive one and the cheapest one, the $200 difference. So this is my measure availability in the data. Okay. In this case, 425 is the cheapest one and 615 is the most expensive one. So there is roughly a $200, or at least a $190, range between the smallest and the largest. Okay. What is the interquartile range? Is the difference between the third quartile and the first quartile. Okay. It is the range for the middle 50% of the data. So this is actually a pretty good representation of roughly where the middle of the data is. Okay. Okay. Not where the middle of the data, but how spread out the middle of the data is. Okay. How spread it out it is. So again, remember it was this one. Yeah. Okay. So it pinpointed it good. And so 525, 445. This minus this is less than 100. So the interquartile range is less than 100. So the middle 50% of the data are pretty close to each other. This is what it's saying. They're within $100 of each other. So you get a whole bunch of rents. 50% of rents are between 445 and 525. This is what it's saying. Or within $100 of each other, you can say, okay? So this is pretty good. It's actually $80, okay? Interquartile range. So again, subtract the third quartile from the first quartile, okay? Lastly is the variance. The variance is a measure. One second. The variance is a measure of availability that utilizes all the data, okay? Okay. It's based on the difference between the value of each observation x and the mean xi. The variance is useful in comparing the variability of two or more variables. The variance is the average of the squared differences between each data value and the mean. The variance is computed as follows. Get each value, subtract it from the mean, square it, and divide by n minus 1. Okay, this is for the sample population. Don't worry about this population one, okay, everybody? I'm going to ask you only for the sample. Okay, the standard deviation of a data set is the square root of the variance. Okay, now the standard deviation has an intuitive interpretation because it is measured in the same units as the data, making it more easily interpreted than the variance. Unlike the variance, the standard deviation has an intuitive interpretation. It is approximately equal to the average distance from the mean. Okay? The larger the variance and standard deviation, the more spread out the data are. Okay? So, how do you compute it? You just take the square root of the variance. Just the square root of the variance. It's that easy. Okay? So, for the apartment rents, I sum all of them up subtracting the mean from each. So first I get, how do you work the formula? I'll tell you what to do. I'm not going to show you all of them, but this says get each observation, subtract it from the mean, and square it. You get a number. Do this with each one of them. Then sum them all up and divide by n minus 1. Now, why do you divide by n minus 1? Shouldn't it just be divided by n? After all, you're trying to take the average distance from the mean. Why do you subtract 1 here? Why don't you just divide by n? It doesn't make it intuitively, it doesn't make sense. Well, let me tell you what's going on. Okay? What's going on is that the problem is the following. I'll tell you, let's do it statistically. I'll tell you what's going on. It turns out that when you divide by n minus 1, s squared becomes an unbiased estimator for the population variance. The population variance, meaning the variance for all of the houses. All of the houses. This is just a sample of 70. I'm talking about the variance if you had the millions and millions of houses and you took that variance. Okay? Okay, so if you took that variance with the millions and millions of houses, you will get some number there, some hypothetical number. This is the true value in a sense, okay? If you divide here by n minus 1, this will be an unbiased estimator for that one, the population variance. Unbiased means on average, it will be correct on average. Sometimes it will be a little bit higher, and sometimes it will be a little bit lower, depending on the sample that you took, the sample of 70 in this case that you took. Sometimes you might take a sample that's more spread out a little bit. Sometimes you might take a sample that's a little bit less spread out. Okay? Okay, everybody? But this is called an unbiased estimator. Now, what is the intuition? The intuition is the following. Why do you divide by n minus 1? By you dividing by n minus 1, you actually want to make s squared a little bit bigger. Because you divide by what? You divide by a smaller number a little bit. So you actually wanted to make it a little bit bigger than it actually should be, I guess, okay? If you were just dividing it by the n. Why do you want to make it a little bit bigger? Well, based on the problem lies in the following. Do you see this x bar here? This is the sample mean. If you actually knew the true mean in the population, so the average price for all these millions and millions of houses, if you knew the true average, you should technically put the true average here. Okay, you should technically put the true average. And then you should subtract each one of them from the true average. But because you're actually putting the sample average, or from those 70 that you averaged, you're putting the sample average, each observation is actually going to be closer to the sample average. On average, is going to be closer to the sample average than the population average. For example, if you knew the population average here, you will not divide by n minus 1. You'll just divide by n. Okay? You just divide by n if you knew the population average. If I told you the average price from the millions and millions of houses is $500, for example, and our sample was $490. But let's suppose in the millions and millions it's 500. If I knew this, it's most appropriate I put 500 here. I don't put 490 here. Okay? And in this case, mathematically speaking, I will divide by n. I will put 500, the true value that it's supposed to be. I'll divide by n, not n minus 1, and I'll subtract each one of the observations from 500. Now, because it's 490, the sum of this squared is going to be a little bit less than when it should be 500 here. When it's 500, it's going to be a little bit more. And you can double check if you want. Put 500 here. Again, this is the, let's assume that, you know, this is just the population average. Anyway, in theory, if it's any number besides 490, this summation here is going to be a little bit bigger if it's a different number than 490, okay? So this is as small as it can possibly be. That's why you have to divide by n minus 1. I hope that makes sense. I mean, let that make sense to you, okay? Let it be. And then for standard deviation, I'm gonna have this S here. I have 54.74. This is saying that on average, the average distance from the mean is $54.74. Okay, so my mean is $490. Okay, on average, houses are plus minus $54 from this mean, plus minus 54. So sometimes they're 540, okay, and sometimes they're what, 440. It's in between 440 and 540. Some of them are more extreme, but this is a good middle. This is the good on average distance from the mean in a sense, okay? Okay, everybody? Okay. So watch. I roll a die and obtain the following 10 numbers ordered from least to greatest. Okay? 1, 1, 2, 2, 2, 4, 5, 6. What is the mean? What is the mode? What is the first quartile and the third quartile? What is the interquartile range? And what is the variance? And what is the standard deviation? So everybody, please pause the video. Try to compute these on your own. You will have something like this on the exam. The first exam that you'll take. Okay, these kind of questions. Okay, so this is a good practice for you. So let's move on. And how do you do this? The mean, you sum them all up. There's 10 numbers here, and I get 3.5. The mode is 4, the most common one, right? What is the median? What is the median? Now, I didn't ask you here for the median, but I guess it's the median. AKA, let's say, I'll tell you what to say. Also known as, okay, 50th percentile, second quartile, like this. Okay, everybody. Okay, it's the same thing. Okay. So what is the median? Well, the median should be the middle one. I count 4 from here, 4 from here. And the two middle ones, 5 from here, 5 from here. The two middle ones are 4 and 4. And I take their average. So the average of 4 and 4 is going to be 4. Okay? What is the good? What is the first quartile and the third quartile? Well, I have the formula here. For first quartile, this is 70, this is 25 over 100, which is 1/4, times n, which is 10, and 1/4 times 10 is 2.5. I round up, so the position is the third position. So the first quartile is the third position, and the number is 2, the first quartile. Then for the third quartile, P is 75, because there's a 75 percentile. I multiply by n, which is 10, and that's going to be 7.5, and that's in the 8th position here. The 8th position is going to be 5. So I put 5. I round up to the 8th, right? What is the interquartile range? Well, it's 5 minus 2. Okay? Which equals 3. What is the standard deviation? What is the variance? You can just plug in the formulas. These are numbers I got. So what is 1.7572? The average distance from the average. The average distance from the mean. So it's about 2. So it's about 3.5 the mean, plus minus 1.72 is about the average distance from the mean. Okay. I want to show you some stuff. Okay. Watch. If we have some numbers like this, I put the numbers here. Okay. And here I type stdev.s equals from here to here. This will give me the standard deviation of those numbers. The mean is here. 3.5 is the average, the mean. The standard deviation is this, and if I put this squared, this is the variance. So that's how I got these. Otherwise, you can just do the math and plug in the formula. Okay, guys. So I think that this is it. Again, you can look over this PowerPoints. I post in the PowerPoints, and I'll see you in class tomorrow. Thank you for listening. Bye-bye.